In this lesson, we are going to learn about cofunctions. Sine and cosine are cofunctions. Let's go on to see why. If you take any right-angled triangle with the angle theta, then the third angle will be 90 degrees minus theta. To get this, you need to subtract the given angles, 90 degrees and theta, from 180 degrees. If we label the sides P, Q, and R, then sine theta, which is opposite over hypotenuse, will be equal to Q over R, and cos theta, which is adjacent over hypotenuse, will be equal to P over R. If we make 90 degrees minus theta the reference angle, then the opposite and adjacent sides will swap places. And sine 90 degrees minus theta, which is opposite over hypotenuse, will be equal to P over R. And cos 90 degrees minus theta, which is adjacent over hypotenuse, will be equal to Q over R. What do you notice concerning these four ratios? Sine theta and cos 90 degrees minus theta both equal Q over R. In other words, cos 90 degrees minus theta equals sine theta. And cos theta and sine 90 degrees minus theta are both equal to P over R. In other words, sine 90 degrees minus theta is equal to cos theta. This is our first pair of cofunctions which we use to reduce 90 degrees minus theta to theta. Please note, sine changes to cos and cos changes to sine. This is why they are called cofunctions. The angles 90 degrees minus theta and theta add up to 90 degrees. We say that they are complementary angles. All the angles involved here are acute angles. In other words, they all lie in quadrant 1. In terms of specific values, it means that sine 50 degrees will be equal to cos 40 degrees, or that cos 25 degrees will be equal to sine 65 degrees. In other words, the trig functions change to their cofunctions, and the angles add up to 90 degrees. In other words, they are complementary angles. If you don't believe that this is true, click the pause button and check on your calculator. There is one more pair of cofunctions that you need to know about. They represent the angles in the second quadrant. Instead of 90 degrees minus theta, we now reduce 90 degrees plus theta to theta. Again, the functions sine and cos change to their cofunctions. And very important to remember, because cos is negative in the second quadrant, cos 90 degrees plus theta reduces to minus sine theta. In terms of specific angles, this means that sine 145 degrees will be equal to cos 55 degrees. This is because 145 degrees is equal to 90 plus 55 degrees. And cos 160 degrees will be equal to minus sine 70 degrees. This is because 160 degrees is equal to 90 plus 70 degrees. If you don't believe me, pause to check on your calculator. We will now use these cofunctions, together with the reduction formulae that we learnt in the previous lesson, to simplify expressions. Please make sure you get to know these together with the cast diagram. In other words, which are positive in which quadrant, when the functions stay the same, and when they change to their cofunction. Here is the first example. To simplify this expression, we need to use both the cofunctions and the reduction formulae. Sine 90 degrees plus theta reduces to cos theta. Cos theta plus 90 degrees is the same as cos 90 degrees plus theta, which reduces to minus sine theta. And using a reduction formula, sine minus theta reduces to minus sine theta. And cos 360 degrees minus theta reduces to cos theta. We now have reduced all the angles to acute angles. And because we have one term over one term, we can cancel as follows. This gives the final answer of 1. Please pause the lesson if you need more time to check my working. Here is example number 2. Let's simplify it together. Cos 180 degrees minus x reduces to minus cos x. So 3 times 180 degrees minus x will reduce to minus 3 times cos x. Sin 90 degrees minus x reduces to cos x. Cos 180 degrees plus x reduces to minus cos x. And because sin 90 degrees plus x reduces to cos x, 2 times sin 90 degrees plus x will reduce to 2 times cos x. We have now reduced all the angles to x. And because we have like terms in the numerator, we can add them to get minus 2 cos x. We also have like terms in the denominator, which we can add to get cos x. We have one term over one term, so we can cancel as follows. This gives a final answer of minus 2. Please pause the lesson if you need more time to check the working. Here is the next example. We are given an expression to simplify, and we are told to do it without using a calculator. In such cases, you need to begin by reducing all the angles to acute angles. To do this, we need to use the reduction formulae. 130 degrees can be rewritten as 180 minus 50 degrees. 240 degrees can be rewritten as 180 plus 60 degrees. 315 degrees can be rewritten as 360 minus 45 degrees. Cos 40 degrees does not need to be reduced because it is already an acute angle. If we subtract 360 degrees from 450 degrees, we get 90 degrees. And 330 degrees can be rewritten as 360 minus 30 degrees. We are now ready to apply the reduction formulae. Sin 180 minus 50 degrees reduces to sin 50 degrees. Tan 180 degrees plus 60 degrees reduces to tan 60 degrees. Tan 360 minus 45 degrees reduces to minus tan 45 degrees. Again, we leave cos 40 degrees as it is. Sin 90 degrees is equal to 1. This is a special angle you should know, but if not, quickly use your calculator to get this value. Cos 360 minus 30 degrees reduces to cos 30 degrees. We have now reduced all the angles to acute angles and are ready to proceed. These 3 acute angles are all special angles. But what about these 2 angles? Do you notice anything interesting? The angles are complementary, and sine and cos are cofunctions. This means that sin 50 degrees is equal to cos 40 degrees, which means we can simply cancel them as follows. For tan 60 degrees, we need to use the 60-degree triangle. Using the fact that tan is opposite over adjacent, we can replace tan 60 degrees with root 3 over 1. By now you should know that tan 45 degrees is equal to 1, so minus tan 45 degrees will be equal to minus 1. We don't need to rewrite the 1, but for cos 30 degrees, we need the 30-degree triangle. This means that cos 30 degrees will be equal to root 3 over 2, because cos is adjacent over hypotenuse. On top we have minus root 3 over 1, and we need to multiply by the reciprocal of the fraction we are dividing by. We then cancel as follows, giving us a final answer of minus 2. Please pause the lesson if you need more time here. Here is a question they like to ask. If sine 20 degrees equals p, express the following in terms of p. Let's answer part A. 20 degrees and 70 degrees are complementary angles. What does this mean? It means that cos 70 degrees is equal to sine 20 degrees, because they are cofunctions. In other words, cos 70 degrees equals p. This completes part A. To answer part B, we first need to reduce 200 degrees to an acute angle. We begin by rewriting 200 degrees as 180 plus 20 degrees. This reduces to minus sine 20 degrees, which in terms of p is minus p. This completes part B. To answer part C, we again need to reduce an angle to get an acute angle. We begin by rewriting the given angle as 90 plus 20 degrees. Then using cofunctions, this is equal to minus sine 20 degrees, which is again equal to minus p. This completes part C. To answer part D, we can rewrite tan minus 20 degrees as minus tan 20 degrees. But this does not really help us. Now what? In such cases, we need to draw a sketch, using the given fact that sine 20 degrees equals p. And you need to think of p as p over 1. Sine is the ratio opposite over hypotenuse, which means that our sketch will look like this. But we are asked to find tan, which is the ratio opposite over adjacent. This means we need to find the length of the adjacent side. To do this, we need to use Pythagoras. The adjacent side is therefore the square root of 1 squared, which is just 1, minus p squared. Minus tan 20 degrees is therefore equal to minus p over the square root of 1 minus p squared. Don't forget that minus sign. This completes part D. Please pause the lesson and check my working. Here is our last example. We are given that x plus y equals 90 degrees and 5 sine x equals 3. We are then asked to use a sketch to find the value of cos x plus sine y. If x plus y equals 90 degrees, then y will be equal to 90 degrees minus x. This means we can rewrite cos x plus sine y as cos x plus sine 90 degrees minus x. Then, using cofunctions, we can rewrite sine 90 degrees minus x as cos x. Next, we need to draw a sketch using the fact that 5 sine x equals 3. This means that sine x equals 3 over 5, which is the ratio opposite over hypotenuse. We can therefore fill in the following two lengths on our sketch, the side opposite angle x and the hypotenuse. We then use Pythagoras to find the length of the adjacent side. To find cos x is now easy. It is 4 over 5. The final answer is therefore 8 over 5, or 1 3/5. This completes the lesson for today. Good luck with your test.